The power rule for differentiation also allows us to differentiate any function looking like this. f of x equals to 3 over x to the power of 4. That's a function which has a simple power of x on the denominator. And the way we use the power rule here is by remembering an important result from algebra. And that's the following. A over x to the power m is equal to a times x to the power of negative m. Now, if you hadn't seen that result before, do make a note of it now. Using that result, we can rewrite f of x in such a way that we'll be able to use the power rule. Indeed, we can now write f of x equals to 3 times x to the power of negative 4. Now that we've done that, we can use the power rule for differentiation to find the derivative function of f of x. Remember, the power rule states that if a function f of x equals to a times x to the power of n, then its derivative function, f dash of x, will equal to n times a times x to the power of n minus 1. Now, comparing the function f of x to the generic a times x to the power of n, we can see that a is equal to 3 and n is equal to negative 4. So the power rule for differentiation leads to the following. F dash of x equals to negative 4 times 3 times x to the power of negative 4 minus 1. And that's equal to negative 4 times 3, which is negative 12, times x to the power of negative 4 minus 1, which is negative 5. So that's x to the power of negative 5. And we could stop here, but having this x with a negative power on it isn't very practical for calculations. So to write our final answer, we're better off using this result again, but reading it from right to left. And doing so leads to the following. F dash of x is equal to negative 12 over x to the power of 5. And that's the final answer. We now have the derivative function of f of x. Let's look at another example. Let's say we have to differentiate f of x equals to 4 over x. Well, looking at this, it may not be obvious right away what the power on the x is. But it's important to realize that when we write x without writing a power on it, it means that we're dealing with the power of 1. In other words, this function can be rewritten as f of x equals to 4 over x to the power of 1. Now that we've done that, we can use the result we saw previously. Remember, that was a over x to the power of m equals to a times x to the power of negative m. And using that, we can now rewrite f of x as a simple power of x, which would be f of x equals to 4 times x to the power of negative 1. We can now see that f of x can be compared to a times x to the power of n, where a is equal to 4 and n is equal to negative 1. And we can therefore use the power rule for differentiation to state that the derivative function f dash of x is equal to negative 1 times 4 times x to the power of negative 1 minus 1. And that's equal to negative 1 times 4, which is negative 4, times x to the power of negative 1 minus 1, which is negative 2. Finally, reading this result we have at the top here from right to left, we can state the final answer as f dash of x is equal to negative 4 over x squared. And that's the final answer. And in fact, functions looking like the one we have here are very common in exam questions. So much so that it's worth spending a minute just to point out a well-known result. Here it is. If f of x is equal to a over x, then the derivative function f dash of x will always equal to negative a over x squared. So for example, if we have f of x equals to 3 over x, Then using this result, we can simply state that the derivative f dash of x will equal to negative 3 over x squared. Or say we're told that y is equal to 1 over x. Then again, we can use this result to state that dy dx, the derivative, will equal to negative 1 over x squared. We could of course use the power rule for differentiation for each of these two examples, but knowing this result off by heart will definitely save us some time. Now let's look at one last example in which we use this result. Say we have to find the derivative function of y equals to 5 over x cubed. Well, again, using the fact that a over x to the power of m is equal to a times x to the power of negative m, we can rewrite this function's equation as a simple power of x, which would look like y equals to 5 times x to the power of negative 3. We can now see quite clearly that we can compare this equation to y equals to a times x to the power of n, where a is equal to 5 and n is equal to negative 3. And so using the power rule for differentiation, we find the following. dy dx is equal to negative 3 times 5 times x to the power of negative 3 minus 1. That's equal to negative 3 times 5, which is negative 15, times x to the power of negative 3 minus 1, which is negative 4. Finally, using this result, reading it from right to left, we can state that the derivative dy dx is equal to negative 15 over x to the power of 4. And that's the final answer. And so that's how to differentiate any function which can be written as a over x to the power of m using the power rule. And that's it for this tutorial. There we go, everyone. I really hope that helped, and if it did, please hit like on this video and even subscribe to our channel, because that really does help us. I'll see you soon.